Hello YouTube and welcome to the 19th Weka tutorial. In this tutorial, I'm not actually continuing Weka tutorial 18 second part because Weka tutorial 18 talked about the knowledge flow environment, and I currently am a bit busy now to work with knowledge flow environment, but guess what? I got some really interesting stuff in Weka and learned this very new technique in Weka. So that's why I'm thinking to give you a tutorial on this, because many people also ask me if this is really possible in Weka to do this stuff I'm going to teach you in this tutorial. So I think this is a good idea to work on with the Weka Explorer again in this 19th tutorial, and I can promise you that when I'm a bit free, when I'm getting away from my research work, at that time I'll make a tutorial on the second part of the knowledge flow environment, because many of you emailed me about the knowledge flow environment, and I'm very glad to see that you guys really like the knowledge flow environment of Weka GUI. But stay tuned. I'm going to produce some more tutorials on knowledge flow. But for this tutorial this week, I'm going to show you something really new that I learned last week. So the thing is that many people ask me this question, if this is possible to find out outliers or extreme values in your dataset with the help of Weka. Not only that, but also you demanded to remove the outliers and the extreme values from your dataset, because you know that outliers and extreme values sometimes deteriorate the performance of classifiers you're going to use on the dataset. So this tutorial talks about how to determine the outliers and the extreme values that are hidden inside your dataset and that are deteriorating your classifier performance. So to work on with that, I'll go back to the Weka Explorer, and I'm clicking that. I'm going to open a file of my own research because currently I'm working on spam detection. So I'm going to talk about spam detection dataset, and it's a very popular dataset, you know. So I'm going to load some of my work that I applied on the dataset. It's called CES DMC 2010 spam dataset, and I'm going to choose 1.r file for today's experimentation. So this is my 1.r file, and you can see that we have over 4,000 instances, and the number of attributes is 21, and the last one is the class attribute. So I'm going to have 20 features in this particular data set, plus one class feature that has two values, PAM and HAM. So my task for the tutorial is to find out the outliers and the extreme values first. Okay, so how am I going to find out the extreme values and the outliers that are hidden inside my dataset? In order to remove them, you have to find them first, right? Okay, to find them, we are going to use the filter, and I'm going to expand the filters here. I'm moving to unsupervised filters. Sorry. Expand unsupervised and instance, and oh no, it's not instance because I'm going to change on the attributes. So in the attributes I have a filter called interquartile range. I'm going to make an abbreviation of that. I'm going to call it IQR. Okay, so interquartile range is a statistical measure. How this works, I'm not going to talk about IQR here. You have to go back to check out on machine learning or data mining books, or even you can check out with the statistical books to find out how IQR works. So I'm just selecting that filter. This filter is going to help me to find out the extreme values or the outliers in my data set. So attributes, and IQR. So I selected that. Here you can see that I've chosen this filter for the test, and you can click in here, and you can find lots of uh, options. And to know more about the options, you can always go back to click on the more button here, and you find a synopsis, how the outliers and the extreme values are calculated. And I'm not going to talk about that, I told you before, because this is not a stat class. So I'm also leaving the values here, the extreme values factor and outlier factor here, just as the default one. I'm showing you how to use that. I'm not going to explain how this works and how you can improve your results. So I'm just leaving that to the default value. So I click OK. So now what happens if you apply, if you click on apply button here, you can see that something is going on. It has stopped and it produced something new. So previously, if you can remember, 2 or 3 minutes ago, I was telling you that we have 21 attributes in this data set. 20 features plus one feature that's called class feature. Here it is. But now we are having two new features. The first one is called outlier. And the outlier, you can see here that its type is nominal, and it has two distinct values, no and yes. So all this is saying is that one particular instance in your dataset, is it going to be an outlier or not? If it is an outlier, then we have something called yes in its label for this particular feature. So this is a new feature, 22nd feature in my dataset. And if it is not an outlier, then the IQR will automatically put a label called no. So I have over 3.5k no's and only 774 yeses here. So this is good for me because I'm not having too many outliers in my data set. Okay, so I'm going to explain more about the outliers and extreme values, but here for this moment you can see that we have another feature included in our dataset. It's called extreme value, and extreme value is also having the type nominal and two distinct values called no and yes. Again, if one particular instance in your dataset is labeled as extreme values by IQR, then IQR is putting a label called yes. And if it finds that it's not going to be an extreme value, it's not containing any extreme value, then it puts a label there as no. So what I'm going to show you now, it's always good practice to save your dataset whenever you're modifying this by using some filter. Otherwise, this is going to be lost when you're closing the Weka Explorer. So I'm going to save this dataset on my desktop, and I'm going to rename this dataset as testing for YouTube. Okay, so it's now been saved on my desktop, and I'm going to read that, open that file, open that R file. You can see that this is a relation, okay, and these are the attributes section. When I started this experiment for this tutorial, I was just having 21 attributes just like this. But when I applied the filter called IQR, interquartile range, at that time, after applying that filter, I'm having two extra attributes now in my R file. Okay, the first one is a nominal attribute called outlier. It contains either no or yes. And I'm having the second attribute, new attribute included in my R file, that's called extreme value. That's also a nominal attribute, and it has the value either no or yes. So for instance, if you want to read a particular instance in your in my data set, so 18.78, 19.36, 36.71, so these all are the values I was having previously up to this point. Okay, so this is my class attribute that is a spam. And then again, I have the 22nd attribute, which is the outlier. So it says yes, that means this particular instance is an outlier, but it doesn't contain any kind of extreme values because I'm having a no here. So this yes is for uh, being an outlier, this particular instance, and this label of no is saying that this instance is not actually containing any extreme values. So in this way, you see that by using IQR, this is very easy to identify if your instances are an outlier or either an outlier or an extreme or containing an extreme value. Now it's time to remove them. So in order to remove them, we are again using a filter here, and this time the filter will be inside the instance uh, folder here. So I'm going to expand that, and you can see that I have a filter called remove with values. So I select remove with values, and I'm going to click on that again to adjust the options. Okay, so the attribute index here, it says that which attribute are you going which attribute are you going to delete or remove from your data set. So I'm saying that okay, I'm going to remove all the outliers. It's going to be based on the 22nd attribute in my data set. So the 22nd attribute is outlier. So that's why I choose the attribute index 22. And again, if you carefully take a look at here, if I click on here, so I'm going to cancel that. I'm choosing outlier, and here, instead of class extreme values, to color this with blue and red with extreme values, I'm going to color this with class outlier. That's a nominal feature. So the blue ones are the outliers, are not outliers, and the red ones are the outliers here. So what we are going to do here, we are going to remove the outliers, the yeses. Okay, so we are having two distinct values here, yes and no. So in this case, I'm going to choose that remove with values feature again, and I'm going to set them up now. So as I told you before, I'm going to remove the outliers from our dataset. So I choose 22 because that's the number of attribute number here in my dataset. And I'm saying that okay, nominal indices first dash last. I'm going to cut that because I'm just going to keep the non-outliers in my data set. So I'm just saying that okay, remove the last one, because in 22nd attribute the last one is saying yes, labeled as yes, because we are having two values here, no and yes. So I'm saying that if that is yes, if that is an outlier, remove them. So that's why I put last here. Okay, so in this way, I just click OK. 22nd attribute, I'm going to remove them. I'm not going to remove all of the 22nd attribute. I'm just saying that, okay, remove only those that are falling inside the last value, which is yes. Okay, so I'm going to click OK here. And I'm again going to apply this filter. And you can see now the outlier yes is completely gone. So if I color that with outliers, there is no reds. Okay, so if I save that, again, testing for YouTube, outlier removed. So I save that on my desktop, and I'm going to view that, and you can now see that this is the outlier feature value. You'll see no yeses there. So I removed all the instances that were indicated as outlier with the algorithm called IRQ, IQR, sorry, interquartile range. Okay, so in the same way, you also can tell, okay, I'm going to remove the extreme values as well from my data set. And in order to do that, I have already chosen the remove with values filter. I click on there, Now I am going to use the 23rd attribute index because that's the number of attribute index number for the extreme value feature. And I'm also seeing here no and yes. So I'm going to remove all the yeses, okay? Those instances that are having extreme values. So nominal indices is last. I click OK. I apply. And now I'm going to save that again with the same name. Okay, so I'm going to overwrite that. If I go back here, so it is now reloading that. Now you can see that the last attribute here that states either whether or not it is an extreme value of this particular instance, you can see that we are not currently having any instance with the last attribute that says yes, because we just removed all the outliers as well as the extreme values from our dataset. So I hope that you got really helped with this idea of removing the outliers and extreme values by applying the interquartile range first to identify the outliers and the extreme values, and then we used the remove with values filter in order to remove the outliers and the extreme values from your dataset. So the reason for removing outliers and extreme values, because some of the classifiers, they really cannot perform when you're having too many outliers or extreme values in your dataset. So I hope that helps. I'll be back with a bunch of tutorial, I promise.